All right, year 10s, here we are again. I'm going to go ahead and just show you some hints for the complex solving of this PSMT. This would garner you a higher mark than a C if you were able to successfully, go down this path. I'll give you some hints. I'll scaffold a very small amount, but ultimately it's up to you to apply, the knowledge and understandings of our probability unit to this particular question. All right. So there is an issue with the current model, right? The current model that I've scaffolded with, there's a major issue, and I'm going to expose it for you right now. So firstly, really, the main issue is that it's so simplistic in the way that it assumes how the match or how the game pans out. Rather, it's just basically saying Djokovic, or, from our previous video, we assumed Djokovic was the person serving, so 1540. It just assumes that Djokovic wins the point in the exact same way 4 times in a row. It's basic. That's not how tennis works. It's not always 1540 and then Djokovic. So let's say this is Djokovic. So Djokovic, and that's Fed. That's the scorecard. It doesn't always happen like this. Djokovic wins the 30-40. Djokovic wins again to 40-40 or deuce, right? Sorry, excuse my spelling. And then add for Djokovic, and then game for Djokovic. Like, Djokovic won't always win 4 points in a row to win the game, right? We know in this particular scenario, Djokovic must get to deuce. Like, that's the position he has to get. Because if Federer wins a point from either 1540 or 3040, then Fed wins the game. You have to get to 40-40 so that both of them have to win 2 games in a row because you've got the add. All right. So we know the model works very well for these first 2 points because there's no other option. Djokovic has to win the first 2 points of this game from 1540. It's at this point where it gets very complex, all right, from the 40-40. And that's what we're going to look at right now, the probability of winning a game from that 40-40 position or deuce. Because we know there are a few more options, and I want to highlight them to you now. So, firstly, the first option, which is obvious, which is part of the C standard for solving this problem, is winning 2 points in a row from deuce. So that's literally what I just said. Going from deuce, or 40-40, to add, and then to game. All right, basic. But we know that's definitely a thing that can happen. That is an outcome that can happen. And we can assign the probability to this by, well, how would you change the probability of winning a point 2 times in a row if you've got 4 times in a row there? Well, yeah, I think that's fairly straightforward. You would just change that number, right? That's a big hint. So that's winning 2 points in a row, right? From deuce. But then there's also another option, all right? Here's the other option. You could win 1 point, right? That would take you to add, remember, from deuce, that would take you to add advantage. You could then lose that point, right? You would lose, because that's the only other option. If you win the next point, then you're just describing the point here. So you could win a point, but then lose, that takes you back to deuce. So win, then lose, you're back in deuce, but then you win from deuce. Just winning the point from deuce. So going to add and then winning again. So 2 points. This is basically not necessarily winning 2 points in a row, but you'll see that there's a bit of there's kind of a bit of an idea here that's quite complex in that this is the option: winning, losing, going back to deuce, but then you have to win all over again because you're back at deuce. And so in here, you could do that again, or you can win 2 points in a row. So this here is actually really complex to think about. but that's an option. All right, so if you don't win and then lose and then win from deuce, you could also lose 1 point, which will take you to add out or break point, right? That means if you lose the next point, you lose the game. That's not what we're after. So obviously then the next option or outcome would mean, you would have to win, and that would take you back to deuce. So it's kind of like the reverse of the second option, winning and then losing, or losing and then winning back to deuce. But then obviously you ultimately have to win that point from deuce to win the game. Okay. So at the moment, they are our three options. I'll just repeat them. So from deuce, winning 2 points in a row, winning a point, then losing a point, but then going ahead and winning that game, and then losing 1 point, winning from deuce, and then, winning back to deuce, but then winning the actual, winning the game from deuce. All right. Let's try and make a bit of a model from here. And I think that's where I'll end the conversation or end the video. All right. So let's say write it from here. And this is the probability of winning, right? Winning from deuce or 40-40. Winning from deuce. Winning from deuce, all right? The probability of winning from deuce would be this option, or this option, or this option. Okay? That's really what it's about, isn't it? So we know what or means, right? So we're going to be adding each of these probabilities below together, okay? But we need to kind of get some variables in place for each of these options, all right? I don't want to write all this again. So let's define some terms, all right? So I'll use a different color now. Let's call winning a point P, all right? Fairly straightforward. That's P for a point. And we know that just is the probability of winning a point, which we've already defined as, kind of this model here, but not winning 4 points, just winning a singular point, all right? That's what that would be, winning a point. So let's go ahead and winning 2 points in a row. That would be, P times P, or just P squared. All right. What about this part here? Winning 1 point here. Well, that's just P, isn't it? There's another one here. That's P. But then we've got losing. So let's go ahead and use red. All right. Losing would be 1 minus P, because losing is just not winning. And same here as well. This here would be 1 minus P. All right. So let's go ahead and just kind of cement this into our model, and I'll use black. So winning from deuce is the first option, which is P squared, plus the second option, plus the third option. But hold on. P times 1 minus P is exactly the same as 1 minus P times P, that is in reverse order. So we have two lots, we have two groups of the same thing. So I don't have to write them again. I could write it once, but just multiply both of them or one of them by 2. All right, hope that makes sense. So we have two lots of this P times 1 minus P. All right, this here relates to both of them, or two of them, right? P times 1 minus P. So let's go ahead and then multiply by the last option. Ooh. What is the last option? Well, the last option came from here and here. Okay? So we had to win from 2 points, or win 2 points in a row, or win a point, then lose a point. But then we kind of forgot, and we're about to add it in now, and then winning from deuce. But we had to then and win from deuce from both options, because really, we always landed back at deuce with this. This gets us to deuce, right? Either through winning then losing or losing then winning. But you still ultimately have to then and win from deuce. So what do we write here? Well, it's just the probability of winning from deuce. That's the probability of winning from deuce. So let's talk about it. Here we go. The probability of winning from deuce is equal to, ready? Winning 2 points in a row, or winning the point, then losing the point back to deuce, or losing the point and then winning the point back to deuce, and then winning from deuce. Because remember, this only gets you to deuce from either winning then losing or losing then winning. You still have to win from deuce. So what's complex about this particular model right now is that we've basically got a term we're trying to determine, right? The probability of winning from deuce, where the term itself is in its own formula. How do we progress from here? Well, we need to eliminate. We really need to find a way to eliminate this somehow. And that's your job, right, from here, is to determine what fundamental idea can we apply, what key idea can we apply here to essentially eliminate this and continue on with our working out. This is not fully completed yet, but I've given you a really big clue here as to how you would progress with this. So just to kind of summarize before I let you go, there was an issue with the current model, right? The current model was that we made a gigantic assumption that Djokovic could only, win a point 4 times in a row. But that's not it. We know you can win from deuce with 3 options, right? So winning those extra 2 points in a row, winning 1 point, then losing a point, going back to deuce, losing 1 point, and then winning a point, that's the reverse, but still both options get you only back to deuce, and then ultimately winning from deuce again. But that makes it complex because winning from deuce is already what we're trying to find because it's already here. That's the problem, right? Why do they exist twice? And what strategy are you going to use to remove this component here? I think that's a big clue there. So I'll let you guys go. I'm sorry for the audio not being in the first video, but here it is. All right. Have a good evening.